Very good morning, students. For this lecturing video session, I am going to solve a problem from sections of solids. Let me just read out the question and make you understand what has been asked and what needs to be drawn. So, a cube of 70 mm long edges has its vertical faces equally inclined to the VP. It is cut by an axillary inclined plane in such a way that the true shape of the cut part is a regular hexagon. Determine the inclination of the cutting plane with HP. Draw front view, sectional top view and true shape of the section. So, given data, here the object is a cube. Here the object is a cube. Cube has 6 equal square shape, isn't it? Right. So, 70 mm long edges. So, S is equal to, that is a side is equal to 70 mm. Right. Has its vertical face equally inclined to the VP. So, the faces, that means this is the object, right? This is the object. These are vertical faces. That means 4 vertical faces are there, isn't it? These are vertical faces. How it is placed? If I keep the object on HP, now these vertical faces are parallel to VP. But what it says, the vertical face is equally inclined to the VP. That means equally inclined in the sense 45 degree with VP. So, if I keep in this manner, now this is 45 degree with VP and this is also 45 degree with VP. Got it? Right. And it is cut by an axillary inclined plane in such a way that the true shape of the cut part is a regular hexagon. As such, here there is no inclination given. That is, the cutting plane is inclined a certain angle and perpendicular to VP is not given, or it is inclined certain angle with VP and perpendicular to HP. So, nothing is given. In place of that, it is specified that a cutting plane is used in such a way that the true shape of this object, that is square, while cutting the object, you will get a hexagon, right? So, that how you obtain, I will explain in detailed manner. And in addition to this, what is asked? Determine the inclination of the cutting plane with VP. So, here one hint is given here. That means determine the inclination of the cutting plane with HP. That means the cutting plane is inclined to HP. What is the conditions? There were 5 conditions, isn't it? So, this condition says this cutting plane or section plane is inclined to HP and perpendicular to VP. So, the cutting plane inclination we don't know, but it is rest assured that it is inclined to HP and perpendicular to VP. So, the cutting plane is inclined to HP and perpendicular to VP. Got it? And the cutting plane is such a way that true shape to be obtained as a regular hexagon. The true shape should be true shape of the cutting part or cut part should be as a hexagon, as a regular hexagon. Draw its front view, sectional top view and true shape of the section. It is mentioned sectional top view. When it's asked sectional top view, therefore naturally the cut is made in the front view. Got it? So, these are the hints which has been given. So, that's the reason I used to say you will have to observe the question, read out the question till you understand, because all the hints should be given in the given question. So, you will have to extract as much as information from the given question. So, here the object is being placed in this manner, right? Now, this particular cube vertical faces are inclined to VP, that is equally inclined to VP. Now the cutting plane is used. What is the cutting plane? It's a two-dimensional object, right? Length and breadth will be there, thickness is negligible. Here it is to cut, the cutting plane should be some inclination with VP. So this is the position, right? So with, but I don't know the inclination of the cutting plane, that is with VP, the corresponding with HP, I don't know the inclination, but this is the position. That means this is how it's going to come, right? Just observe what I am going to draw. First I have to draw the XY line. See, as far as sections of solid is concerned, the true shape always obtained on the HP, isn't it? So draw a reference line which is nothing but the ground line XY, above XY is VP, below is HP. So here the side of the cube is 70 mm. If you draw, that will be too big, that the drawing should be very big. So in order to reduce the size, I am going to consider the scale. So I am going to consider the scale as half. That means 1:2. The scale should be 1:2. I am going to consider 1:2. That means half. 1:2 is nothing but 1/2. That means whatever dimension given here, I need to consider half of it. Right. So that means, so here the side is 70. Therefore, I need to consider 35 mm as side. This is equal to 70 by 2, 35. So take 35, right, as a side of the cube. Here the object is kept 45-degree inclination with, that is equally inclined with VP. So keep your protractor in this manner and take 45-degree, something like this. So draw a inclined line, right? This inclination is 45-degree because it is equally inclined. It is equally inclined, therefore this should be 45-degree. You know the side of the cube, that is 35 mm. Choose 35 here. So 35. Right. Now draw a perpendicular line to this inclined line, that is extend, you just extend it. Extend it. Now take 35 in your compass, keep it over here and cut an arc. Similarly, keep the compass over here and cut an arc here. Now close this. So this is the cube. So in the top view, you could see a square kind of thing, right? As far as cube is concerned, 6 regular equal square shape, right? So as far as sections of solid is concerned, don't draw anything as dark initially, because we don't know where the object is going to cut. So therefore, don't draw anything as dark. So as far as the top view is concerned, it should lie on the same line because it is equally inclined. So it should come on the same line, right? It should come on the same line. So this is a square. So the top view, there is a face, that is the top face, I am going to give the naming as ABCD. And the bottom face, that is the base, I am going to give PQRS, because which are invisible. PQ, R and S are invisible. Top view is over. Now I need to project all the corners vertically, that is projectors. Take all the projectors vertically upwards. Take projectors vertically upwards. Vertically upwards. Clear? Now, what is the axis height here? See, as being cube, this should be, the height should be 35 because all the 6 sides of equal shape and dimension. So, from this is the axis, right? If you just connect the diagonal, so this is the axis. So, from the reference line, take 35 mm and cut an arc. So, now close it. So, this is the view which you will get it when you look at the object orthogonally in front of the object, that is cube. So since here A, B, C are visible, right? A, B, C, D are visible. When you look at from here, look at here, A, B, C are visible. When it is visible, it should go above. So this should be A dash, this should be B dash, and this should be C dash. What about D dash? D dash is right behind B, therefore it is invisible. That should be captured within the bracket. Clear? Then what about the bottom face? That is P, Q, R are visible. P dash, Q dash and R dash are visible. What about S dash? S is right behind Q, therefore S is invisible. S is invisible. Right. So now we are going to cut the object by using the cutting plane or section plane. So in order to get the 6 sides for a regular hexagon, the object is being tilted in this manner. The cutting plane should pass through all the edges, that means the top edges and the vertical face and the bottom edges. Therefore, you will get 6 sides. If you cut the edge, you will get 2 points, isn't it? So, what I am going to do is, I am going to choose the midpoint of BC and CD. The midpoint of BC and CD. So, somewhere here. Next, the midpoint of PQ. Right. So, it is somewhere here. Now, the midpoint of BQ and DS. So, which is somewhere here. Right. So, this is the midpoint of BC and CD. This is the midpoint of PQ and PS. And this is the midpoint of BQ and DS. Now, draw a line passing through all the 3. Now, draw a line passing through all the 3 points. Right. So, it should be like this. So, what did I tell you? When the cutting plane is used to cut the object, the major portion should be considered as remained portion and the minimum portion as considered as removed portion. Which is the maximum portion? This is the maximum portion. So, you just keep it, this portion as remained portion. That should be drawn as dark. That should be drawn as dark. Let's say everything should be a construction line, that is a thin line. So, this is what. How to specify the cutting plane? In this manner. So, this should be widen. So, both the ends should be widen. So, now the cutting plane is used. So, while cutting this, this is also visible, isn't it? While cutting it, the new corners or edges are formed. Right. Look at here. When you cut it here, the base, when the cutting plane is cut the base, you will get 2 points. Therefore, 1 dash and leave a bracket, because one is visible, the other edge would be invisible, because that is will be behind it. Similarly, here when it cuts here, 1 point would be visible. Visible should be considered as 2 dash and leave a bracket for the invisible thing. Right. So, next, the top face. There also 2 edges would be formed. So, visible as considered as 3 dash and leave a bracket. Now, starts from here. The invisible 4 dash, 5 dash and 6 dash. Clear? Now, this is the front view. Now, I need to draw the sectional top view, for which I have to extend these lines from the newly created edges or the corners. Now, draw a vertical line that should be perpendicular to the XY, that is the reference line. Extend this line vertically downwards. Similarly, this also I have dropped, and 3, 4, just draw a vertical line. Got it? Now, this line, that is 1 would be visible. So, it should come between A and B or P and, yes, that is PQ, right? So, this should be considered as 1. And look at here, this is visible 1. So, this should be considered as 2. And here 3 is visible, therefore, it should come here, 3. And the behind, which are invisible to you, so those points are 4 and 5 is somewhere here and 6 is somewhere here. So now, which portion is visible to us when you look at from the top? So these are the portion would be visible. These are the portions which would be visible. And the balanced portion, what about the balanced portion? So here, this is visible. Again, this is visible because when you just look at from the top, this would be visible. This portion is removed. This particular portion is being removed. Balance, everything is visible. So here, as far as this hexagon shape is concerned, this is the cut has been made by using the cutting plane. So the section line needs to be drawn or the hatching line needs to be drawn. The hatching line should be 45-degree inclination and the gap between two lines, that is section lines or hatching lines, should be 1 to 3 mm gap. Either 1 to 3 mm gap. If you maintain 2 mm, then all the gaps should be of 2 mm gap. If you are maintaining 3 mm gap, then maintain 3 mm gap. So what I am going to do is I am going to draw the section lines here. That should be 45-degree inclination of 3 mm gap. So only this location, only the cutting plane is used. So for this area, you should not hatch the line. If the cutting plane should have passed here, then you could do the hatching line here. So only this portion alone the cutting plane is used to cut the object. Therefore, you should hatch only the areas where the cut is being made. So this is the sectional top view, right? Then what about the true shape of the section where you will obtain? You need to draw a new reference line which should be parallel to the cutting plane. Which should be parallel to the cutting plane, right? So now I am going to draw a parallel line. It should be parallel to the cutting plane. And let me just put this as x1 and y1. Clear? Now I need to draw the projectors from the newly created corners that are points, right? That should be when the word projector, that means it should be usually perpendicular to the cutting point. So it should be perpendicular to the cutting point. Draw a perpendicular lines from all the newly cut lines. It should be perpendicular. This should be 90 degree. This should be 90 degree. This should be 90 degree. Right. Now, this is the old reference line and this is the new reference line. Right. So now, I have to measure each and every corners. That means 1, 2, 3, 4, 5, 6 are the newly created corners. I need to measure it from the existing reference line. So, measure it from the reference line to 1. Stretch your compass from the reference line to 1. Stretch your compass. Now, look at here, the line where it goes, the one comes here. This is a new reference line. Now, stretch your compass and cut an arc. This is nothing but the distance between 1 and the reference line. Therefore, this should be, here you have mentioned 1 dash, therefore 1 double dash. Clear? Now, on the same line, point number 6, there is one more corner is there. Now, measure it from the reference line to 6 and look at here where it goes. This is the reference line and stretch your compass and cut an arc. So, this is nothing but 6 double dash. Let's move to the next edge, which is 2 and 5 corners are there. Now, stretch your compass from the reference line to 2. Stretch your compass from reference line to 2. Measure it and look at this, where the projectors are going. here. This is a new reference line. Now stretch your compass and cut an arc. This should be 2 double dash. Now one more corner is there, that is 5. Measure it from the reference line to 5. Stretch your compass from the reference line to 5 and look at here where it goes. This is a new reference line and cut an arc here. This should be 5 double dash. Clear? So 2 should be somewhere here. This should be 2 dash. And 2 more corners are there, 3 and 4. Now keep your compass here from the reference line to 3. Stretch your compass from reference line to 3. And look at here where the projector is coming here. This is a newly created reference line and cut an arc. This should be 3 double dash. One more corner, that is 4 is there. So stretch your compass from the reference line to 4 and look at here where it goes. Comes here, this is a new reference line and stretch your compass and cut an arc here. This should be 4 double dash. So how the hexagon is formed? By connecting 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 1. This is how the regular hexagon has been formed. So same thing I am going to do now. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 1. This should be thin line. Right. Now this is the regular hexagon is obtained when the observer look at this cut surface orthogonally to the cut surface. Right. So this is the true shape of the section. When the word says section, that means section line needs to be drawn. So which should be 45 degree inclination. Should be 45 degree inclination. And the gap between two lines should be 3 mm. Hatch it. So this is the true shape of the section. So with this I have completed all the 3 views, that is front view, sectional top view and the true shape of the section. Next what I have to do? I have to mark the dimensions, isn't it? So the dimension as being cube, I need to specify the drawing. Though I have considered the scale as 1:2, the dimension should be marked as the actual dimension, that is 70 mm. Though you have considered this is 35, right? But you have considered the scale 1:2, right? So while mentioning here, you should specify this as 70. This as 70 mm. So in the question, it is asked, determine the inclination of cutting plane with HP. So you will have to find the theta value. That is, this is the cutting plane. This is the theta. This is theta. Keep your protractor in this manner and measure it what angle you get. So that you specify it whatever angle you get. So as far as this diagram is concerned, it is something around 55 degree or so. This is theta. Theta is nothing but the inclination with HP, isn't it? So I have completed everything. Now I need to draw or write the notes. So first open up a guideline of 5 mm height. You need to specify all dimensions are in mm. All dimensions are in mm. Are in mm. And the scale, so scale should not be written here for your understanding only. I have written here. This needs to be specified here with a guideline. Of 5 mm height. So the actual scale, the scale which I consider is a reduced scale. Therefore, it should be 1:2. So in the usual thing, if the dimension of the cube is given 30 mm or 20 mm, you need not to reduce the scale. Here, if it is 70 mm, when you just start drawing as an inclined manner, it should be such a big one, or the drawing should go beyond your the given paper, that is A3 paper. So accordingly you will have to select the scale. Here I have considered scale 1:2. Hope you have understood how to construct this kind of problem when this twisted question is being asked. Thank you.